All right, in this video, we're going to start with looking at quadratic formulas. Now, we're looking at your pink notes right now, and you should have your linear function on there. You should have the absolute value function completed. And so today, we're going to start with the quadratic. So this is note 7.1, and we're starting with quadratics. Now, with quadratics, maybe you learned this to remember this from Algebra 1. It is the function of y equals x squared. It makes a parabola shape. So when we plot our points, we're going to start with the origin at 0, 0. And if my x value is 1, if I plug a 1 in my equation for x and squared, I get a 1. If I plug a 2 in my equation, I get a 4. So it goes up 1, 2, 3, 4. And then on the negative side, if I put in a negative 1 in squared, I get a positive 1. If I put a negative 2 in there, I get a positive 4. So you can see the parabola shape. Got to have the arrows at the end and the nice curved shape. Now the points that you want to make sure you always use to start with are 0, 0, 1, 1, x is 2, y is 4, and then the negative side, negative 1 squared gives me a positive 1, negative 2 squared gives me a positive 4. So these are going to be the main points you want to use, and you're going to use this relationship of go up 1, over 2, up 4. So these values are going to help us as we graph transformations of quadratic functions. So let's go back to listing out domain and range and all the things we need to do in both set notation and interval notation. So our domain, recall that our arrows are going this way, so that means all x values will be used. So we would set our notation as x such that x is an element of all real numbers. Remember, in interval notation, it looks like this, negative infinity to positive infinity. My range is the lowest y value to the highest. Well, the lowest y value is 0, so it's going to be y such that y is greater than or equal to 0. And I'm going to put a hard stop on that 0, so it's a bracket, comma, positive infinity. Now the x-intercept, where does it touch the x-axis? That's at 0, 0. And my y-intercept is at 0, 0. Okay, and this one has no asymptotes, so you would write none. So we're going to use this parent function to help us do our transformations of quadratics. So these, again, these points in this relationship right here are going to be really key for you as we graph our transformed points. All right, let's look at the lesson page 471. Okay, here we go. So here's the equation for vertex form of a parabola. So let's break this equation down a little bit. Now this a value is very similar to what we did with the absolute value graph. It is going to be the vertical stretch or shrink. And remember, if a is, it goes with logic, so if a is big, then it's going to stretch it. If it's small, like between 0 and 1, it's going to shrink it. H is what's happening left and right. Okay, it's opposite logic, remember? The K is the vertical shift. It's either going up or down, and it goes with logic. So this formula is called vertex form because you can look at it and see the H and the K, which is your vertex. H and K. Now, H, you got to remember that you have to change the sign on that H. Now, K is exactly the way it appears in the equation, but the H does change. Now the axis of symmetry is going to be x equals, and it's going to be h. Whatever that h value is in your vertex, that's what you're going to use for your axis of symmetry. Now let's look at this a value for a second. Right there, that a value in the front, if it's greater than 0, then the graph opens up. Okay, and by greater than 0, I mean positive. If it's positive, it's going to open up, and This vertex down here is at the bottom, and we call that the minimum. So if a is less than 0, that's a fancy way of saying if a is negative, that means our parabola is going to open down. And you can imagine that vertex right here is not a minimum, but now we call it a maximum. Okay, so let's look at the rest of our paper and see what it is we're going to be doing today. So let's break down our instructions for a moment. It says state the vertex, then graph each function, state transformations from the parent function and the domain and range for each in set notation. All right. So let's first go through all of these and just do the vertex. All right, let's just do the vertex and you'll see how handy the vertex form is. So the vertex is going to be, remember, it's H and K. From up here, it's H and K. I remember the order with Hello Kitty, H and K. So I look in the same location in my equation for H and K. And I just remember I need to change the sign of H. So it's not -5, it's going to be 5. And then the K part stays the same, so it's 5, -2. Let's just run through all these and do vertex really quick. So let's look at number 2. Look at my H. It says -1 there, so my vertex, it's going to be actually a +1. There's nothing added or subtracted, so it's 0 for K. On number 3, notice there's no parentheses there with the x squared. That means that my H value is 0. The +4 is hanging off the back end, so that's my K value, so 0, 4. Come back over here to number 4. My H value, that +2, I got to change the sign, it's -2, and that 1 hangs off the back. Number 5, it says -3 in the equation, but I know that's going to be a +3 and a +4 for K. And then number 6 down here, it has a vertex of -1 and -5. So that's how we find our vertex. Hopefully you found that to be pretty straightforward. Then it says to graph each function. State the transformations from the parent function and domain and range. So let's do that middle section. Let's state the transformations and graph them. So let's look at number 1. So that -5 inside, remember in the parentheses, it's going to go opposite logic. So this is going to move right 5. The -2 means going to move down 2. All right, so I know my vertex is at 5, -2, so I'm going to move it there. 1, 2, 3, 4, 5, down 2. And my A value, notice it's not written, but that just means it's a +1, so it's the regular slope. And this is where you want to remember that parent function. Remember it went up 1 over 1, 1 and 1, and then went over 2, we went up 4. That stays the same. And then you might consider this. So this is 1/2 of your parabola, right? Well, it's symmetrical. So if you want to consider this axis of symmetry, if you imagine a dotted line right here, and you just reflect it across, it's going to go up 1 over 1 to the left, up 2 over 2, up 4 on the right, on the left again. So here we go. So there's my transformed parabola. Let's look at number 2. Our vertex is at 1, 0, and our A value is just 1. So transformations, what has happened? It's only moved right 1 unit. It hasn't moved up or down. So remember our parent points, we went over 1, up 1, over 2, up 4. That hasn't changed because that A value is the same. So I'm going to do the same thing on the left side. Over 1, up 1, over 2, up 1, 4. And I'm going to draw my curved line with my arrows. There's my new equation. Let's try number 3. This one, the vertex we said is at 0, 4. 1, 2, 3, 4. So what has happened? All that's happened is it's moved up 4 units. Now, that A value is not written because it's just a regular old 1, which means it's going to look like the parent function. It's going to go up 1, over 1, up 1. Over 2, up 4. And then I do it down the other direction. Over 1, up 1, over 2, up 4. All right, so far no big changes in the slope, okay? No big deal, but let's try some more challenging ones. Let's look at number 4. All right, this one has a vertex at -2, +1. Now, notice what transformation. Remember this lead negative? That means it's going to reflect over the x-axis. What's happened? It has moved left 2 units and it's moved up 1 unit. So it's going to open down. That means it's going to open down. And it's opening down, but it's the A value is just 1. So it's going to go over 1, down 1, over 2, down 4. And then do the same thing going down the left side, over 1, down 1, over 2, down 4, and draw a smooth curve with arrows connecting. And there's our transformed parabola. Let's look at number 5. So we've put our vertex at 3, 4. 1, 2, 3. Right there. Now, we can list our transformations. We're going to go, let's see, we're going to go right 3, up 4, vertical stretch by 2, and it's going to reflect over the x-axis. So, got lots going on here. Now, when I go to graph this, I know it's going to go upside down. So I'm going to go over 1 and normally go down 1, but my A value is a -2. So I'm going to take that 1 times -2 means I'm going to go down 2 instead. So I'm going to go down 2. And then if x goes over 2, we normally go down 4 from the vertex, but 4 times -2 means 8. So if I'm counting from the vertex, 2 over 1, 2, 3, 4, 5, 6, 7, 8. And I come around, come across, here it is, and then it reflects. So it should be a smooth curve doing just this. Now let's look at number 6. We have our vertex at -1, -5. Let's list our transformations. Okay, the 1/2, that A value, is a vertical shrink by 1/2. +1 means it's going to go left 1, and the -5 means it's going down 5. So left 1, down 5, 1, 2, 3, 4, 5. All right. Now, this one is going to be shrunk by 1/2. So when I go over 1, I'm not going to go up 1. I'm only going to go up 1/2 because 1 times 1/2 is 1/2. I go over 2. I normally would go up 4, but 4 times 1/2 gives me up 2. And I could keep going, but I'm just going to reflect it across that line of symmetry and go from there. All right, there it is. There's number 6. Now let's keep going. Number 7, let's look at this. The parent function is stretched vertically by a factor of 8, so that's in the front. Translated 7 units down, so -7 in the back. 3 units to the right, which means it would be -3 in the squared portion of my graph, or equation. And then reflected over the x-axis, so it's going to have a negative in the front. So I'm going to have -8, x minus 3, don't forget the squared, and then the -7. So now let's look at this one. Number 8, without graphing, identify the vertex, axis of symmetry, and the transformation. So vertex first, I'm going to have a vertex of 4, 0. Axis of symmetry will be x equals whatever my x-coordinate is, which is 4. And let's list transformations. Well, there's no A value. A is 1, so that's fine. It's not negative, so it's not reflected. It's going to go, let's see, right 4 units. It's not going up, it's not going down, so that's really the only thing happening here is going right 4. Let's look at 8, 9, and 10. Write the equation in vertex form for each graph. All right, so let's first find our vertex, okay? So this is at 2, 2. So I know it's going to be x minus 2 squared plus 2. Now let's decide if the a value is just 1. So if I go up over 1, up 1, that works. Over 2, does it go up 4? 1, 2, 3, 4. So since it fits the pattern, then it just has an a value of 1. You don't have to write that, but you can. So there's my answer. Vertex we said was 2, 2. There it is. All right, so let's look at 10. Find our vertex starting point. It's going to be at negative 4, 2. So I know my equation is going to be x plus 4 squared plus 2. Now let's figure out what's going on in the front. We know it's reflected vertically, so it's going to be negative something. But let's figure out what it is. So the parent function would say it would go over 1 and down 1, but doesn't quite go down 1 unit. So it looks like maybe 1/2. Well, let's find out if it is 1/2. Let's try this. So if it's 1/2, if I go over 2, normally it would go down 4, but half of 4 is only 2, so that works. I could keep testing it if I wanted to go 3. If I go out 3, it should go down 9. It only go down half of that, which is 4.5. 1, 2, 3, 4.5. That does work. So for sure, that a value is 1/2. I hope that makes sense, and we'll continue working on this in class.